explain the working of capacitor voltage transformer. So a CVT, that is capacitor voltage transformer, works on the combined principle of capacitive voltage division, that is the capacitor voltage divider, up to a first level of voltage division from a very high voltages to a small level of measurable or some few kilovolts, like from 66 or above, that is 132, 220 or 400 kilovolt to a few kilovolts value, and electromagnetic transformation action from the first stage output of few kilovolt voltage reduced at the intermediate level across voltage C2 capacitor, that is to be transformed with the help of the transformer to the secondary side of the potential transformer to a standard measurable value, that is 110 or 110 by root 3 value. It is mainly used for high voltage measurement and power line carrier communication for the communication purposes. The incoming high voltage line is connected to the capacitive voltage divider made up of two capacitors connected in series, that is C1 and C2. This C1 is a high value or high voltage capacitor and C2 is the low voltage capacitor. So the total voltage line voltage V1 is divided according to the capacitor voltage division principle. So V2 is equals to V1 into C1 upon C1 plus C2, the combination. Since the value of C1 is very small as compared to the C2, most of the voltage drop appears across the capacitor C1. So only small portion appears across the secondary capacitor C2 or the second capacitor C2. Now the reduced voltage across C2, that is at intermediate voltage, is fed to the primary of the electromagnetic transformer. This primary winding is connected in series with a tuning reactor connected in the circuit. The tuning reactor is designed to resonate with the series capacitance C1 and C2, the combination, at the system frequency 50 or 60 Hz. It is provided to improve the voltage transfer, reduce the phase error and ensure the accuracy and efficiency for metering and protection purposes. The intermediate transformer steps down the intermediate voltage from few kilovolt to the standard secondary voltage of 110 volt or 110 by root 3 volt RMS values. This low voltage output is then supplied to the meters, relays or communication equipments for the further actions. Damping circuits absorb switching transients and prevent oscillations. Ferroresonance suppression circuits protect the CVT from dangerous over voltages during certain switching or faulty conditions. In addition to voltage transformation, the capacitor voltage transformer CVT can couple high frequency communication signals, that is from 30 to 500 kHz value of the frequency, to the tower line or the power line for the PLCC, power line carrier communication. A coupling capacitor inside the CVT allows high frequency signal to pass while blocking the power frequency current from entering the communication signal or equipment. The capacitor voltage divider can work satisfactorily only when the value of the current taken by the burden, that is the secondary circuit impedance is connected in the secondary side of the potential transformer, is less than the current of the series divider. For this, an inductor L is connected in series of the primary circuit, whose value can be determined with the equation L is equals to 1 upon omega square C1 plus C2, where omega is the frequency calculator or the angular frequency 2 pi f. So this is how the working of the capacitor voltage transformer is understood.